Okay, is this is the one you're looking at?
Yes, I thought it was a multiplication sign, but my friend looked closer and it's addition.
Okay. Maybe,
It's
but
a little, but I could see it.
yeah, it's like when I see a plus, like I'm looking over at number 3, like there's a big plus.
Yes. This,
So I'm trying to say I strongly suggest it's not a plus. I'm happy to do it with a plus, but I don't agree with it.
okay, I have no idea, honestly.
Okay, let's do it as if it's a multiplication.
Okay.
Okay, so it's 3 things. This square root of negative 15 is the square root of negative 1 times the square root of 15. Okay, is that all right?
Yes.
Okay, so that's I, and that's the square root of 15. That's just what it is. The square root of negative 3 is the square root of negative 1 times the square root of 3. So the mistake is to try and multiply these numbers because you end up getting the wrong sign, first of all. And these are all multiplying together. So you can choose to multiply these together. That's I squared. Okay. So I squared is negative 1. So you have negative 1 in the top, square root of 15 times the square root of 3. On the bottom, you have the square root of 5. Is that okay so far? All right, so see, if you multiply negative 15 and negative 3, you end up getting a positive 45, which gets rid of this negative, which is wrong. So the next thing is you should multiply these two numbers inside the root. Because they're both positive, you can do that. So it becomes negative 1 square root 45 over square root 5. And if you have the square root of a over the square root of b, it becomes the square root of a over b. So you can actually divide these numbers.
Which is 9. Square root of 9.
Square root of 9, you're like, oh, I know that. That's 3. So this becomes negative 3. Is that okay?
Yeah.
Okay, two. Would you like us to do 2?
I already did 2. The one that I need help on is number 6.
Sure. Yeah, this is a good one here. This, you're going to definitely get this on the test. 6 includes things from 3. So that's why you're more likely to get that. Although you might get both, I'm not sure. You have to multiply the bottom by the complex conjugate. And all that means is it's the same thing, but you change the operator. So instead of plus, it becomes minus. And then you have to FOIL the top and the bottom. Okay, so the top, we'll do the top first. So the top is 12, and then the outside is minus 9i. The inside is minus 8i. And then the last is positive 6i squared. The bottom, when you FOIL it, you're going to see that the outer and the inner terms cancel. Okay, so so these cancel. Let me start there. And then remember, I squared is negative 1. So wherever you see an I squared, you can replace it with negative 1. So this becomes negative 6. And this becomes positive 9. So it's 12 minus 6, which is 6, minus 9i and minus 8i is minus 17i, all over 16 plus 9. And we're not quite done. There's more to do here. So the bottom is 25. So I'll just write it off to the side here. 16 minus 17i over 25. You'll see this a lot. Your instructor might say, write it in this form. Well, this means that there's no fractions on the bottom here. So you have to divide each of these by 25. And this is your final answer on that one.
I did 7, 8, and 9. I didn't do number 10. I don't know why I did not do number 10. But is that just boiling or factoring?
Let me get caught up here to you. I was figuring you're getting caught up. So just a moment here. My apologies for being. Okay. So number 10. Sorry about that. It says to solve. This one you have to factor. Is that what you're saying?
Yes.
Okay. Would you like us to look at it together?
Sure.
Okay. So this is the case where a does not equal 1. That's the first one here. So there's two choices. There's the guess and check or the grouping. So the guess and check, you end up making two cases. You say it's 2x and 2x, or it's 4x and 1x. The grouping is where you take this 4 and you multiply it by this 2. Which do you normally do, or which do you prefer for us to do?
We usually do the grouping.
Okay, so ignore that on the left there. So 4 times 2. So now you're looking for two numbers that multiply to 8, but add up to -3. So we know they have to be both be negative. But you see me sort of stammering here. None of these work. So that means you have to use quadratic formula. So we have to use quadratic formula on this. So our preference here is factor, and then quadratic formula, maybe completing the square. So we do have to use quadratic formula. So a equals 4, b equals -3, and c equals 2. Thank goodness the numbers aren't too large. So it's minus b plus or minus the square root, b squared minus 4ac all over 2a. And I assume you're familiar with this. Like, this is not something new.
No, yeah.
Okay. Just as reminders, when you substitute for negative numbers, it's usually good to put them in parentheses. We're really hoping that the bottom of the part inside the square root is positive or a perfect square. It does not look like it's either. So this part inside the square root, that's kind of the key thing there. It's 3 plus or minus square root of 9 minus 32. Okay. And actually this makes sense, because if you go back to the very first problem you showed me, we're dealing with complex numbers, so it makes sense that you would get a negative in here, because these are I problems, we'll say. So the square root of -23 is -1 times the square root of 23. So that's where that I comes in. So you write it this way: 3 plus or minus I square root 23 over 8. And then, just like the previous problem, you have to divide each of these by 8. It's not a choice. You just have to show both.
Yeah.
So it's I square root 23 over 8.
Did 11. Can we do number 12?
Yes. Okay, that's on another page. The back. Okay, divide. All right. So you must have been doing, there's two types of division. There's long division and then synthetic division. The instructor isn't being very clear here, but we're going to assume that they do not mean synthetic division, because they usually want you to do at least one problem where you write x minus 3 on the outside, and then the other one's on the inside. Now, this one is missing 0x to the power of 1. Do you see that?
Yes.
And that's why it's here. This is your test question, because that will be on a test. And you'll all right. So do you remember how to do this from class?
Yes.
Okay. So I might use some different words, but you're essentially trying to figure out what do you get to, we need to multiply x by something to get x cubed, and that's x squared.
Mhm.
So it's x cubed minus 3x squared. And then this is the kind of the tough part, is you're subtracting. So it's x cubed minus x cubed. That should always be 0. This one, though, might not be, or it might be minus 3x squared minus a minus 3x squared. So that's positive. So that's 0.
Mhm.
And then you start bringing these other terms down. This is really odd that this one works out so well. So, um, so this is the, I mean, the because nothing else is going to go here.
Mhm.
I mean, usually you like it would be 0x because that gives you the 0. It gives you the x. I mean, it's just, it's odd that it works out like this. So and then this is 0 here as well. So your remainder is 5. So the answer here is, and it's written this way, it's quotient plus remainder over divisor.
Mhm.
This is your remainder. This is your quotient, and this is your divisor. So your instructor's looking for x squared plus 5 over x minus 3.
And then I did 13, but then I didn't do the rest of the page.
Okay. Did you use synthetic division for 13?
Yes.
Okay. All right. Do you think this will be very similar to the exam, like just changed numbers?
Yeah, I think so.
Okay. I ask because I want to tell you how to do these, and I mean, there's other things in play if these are not exact,
Yeah.
exactly what you want to do. So this is solve using the zero product property. All that means is you need to get this factored first, factored form. And whenever you see a third degree polynomial like this, you generally are going to do grouping.
Mhm.
So what is common between x cubed and 3x squared?
They both have an x squared.
Yes. And then you immediately, what you do is you take this thing that's inside here and you immediately write it over here. And if you've done it right, and if it works, you should be able to put a number here or number and letter here so that when you multiply it in, you get back to the previous line. So it happens to be minus 8, because that gives you minus 8x, check. Minus 8 times minus 3 gives you positive 24, check.
Mhm.
And this is called factor by grouping, but it's really double. To me, it's like double factoring, because you got to factor the x minus 3 out of both of these. Like this is a term, this is a term, and they both have x minus 3 in it.
Mhm.
And then you put the other things, you bring the other ones down.
Okay.
Okay. So now you set each of these factors equal to 0. And that's what it means by the zero product property. So and you already know to do this. X minus 3 equal to 0, x squared minus 8 equal to 0. And you got to solve. So x equals 3. So the one on the right here is a little bit tougher. X squared equals 8. There's two solutions. When you take the square root of both sides, it's plus or minus. So x equals plus or minus square root of 8.
Mhm.
But we have to reduce that. Your 8 reduces, your 8's 2 and 4, 2 and 2. So x equals plus or minus 2 square root 2. So these are your two kind of answers, I guess.
Mhm.
Three answers. Okay, so we're going to move to 15. Okay, describe the end behavior of the following and degree of the following. So there's like 4 graphs that you need for this.
Mhm.
This is for odd exponents. These are both for odd exponents. So the first one is for a greater than 0, a positive, and a is this. So like it means for odd exponents, you start low and you end high. So we don't care what it does in the middle here, but it always starts down here and ends up here.
Mhm.
When a is less than 0, it goes the other way. It starts high and ends low. So do you see that this p of x is this one over here on the right?
Yes.
Okay, great. So now we have to have the end behavior. So some textbooks say this really strangely, but it's better to say as x goes to infinity, as x goes to negative infinity. So as x goes to infinity means over here on the right,
Mhm.
the right side here. So how far down is that going?
Negative infinity.
Negative infinity. And then when you go the other way, as x goes to negative infinity, f of x goes to positive infinity. Now, if this were a 4, it would be totally different. But if it was a 5, it would be exactly the same.
Mhm.
Do you want the graphs for the even exponents, or do you have those in your notes?
I have those in my notes.
Okay, great. 16. 16 says to find a quadratic in vertex form that has, vertex form that has a vertex of 3, -4. So that's h comma k. And your vertex form is a x minus h squared plus k. So we've got h, and we've got k. So this is y equals a x minus 3 squared minus 4. So now this is an x and a y over here. This is a point. Point means an x and a y. So if I give you an x and a y, the only thing that's left over here is the a. So we're going to use those values in here. Y is 2, x is 1. And we're going to solve for a. So you're going to add 4 to both sides. So that's 6 equals a. 1 minus 3 is -2 squared. So that's 4. So 6 equals 4a. Divide both sides by 4. So a equals 3/2. So that means you go back to this line right here.
And then just plug it in.
Yeah, just put that in. So it's y equals 3/2 x minus 3 squared minus 4.
Okay, perfect.
All right, so 17.
Yes.
All right. So whenever it says greater than 0, less than 0, you want to ignore that. You essentially want to assume it's equal to 0 for the moment. And this one you can solve by factoring. So two numbers that multiply to 20 but add up to 9. That's +4 greater than 0. So do you remember what the shape of a quadratic looks like?
It's like a U-shaped.
It's a U shape. Okay, so here's what this tells us. This tells us, believe it or not, that at -4, 1, 2, 3, 4, and -5, that it hits the x-axis. So this has this shape right here, something like that. We want to know where it's greater than 0. Greater than 0 means above the x-axis. So if I were to draw a number line, here's -4 and here's -5. When you're left of -4, do you see that you're above the x-axis?
Mm-hmm.
And when you're right of I'm sorry, I got these numbers backwards. -5, -4. When you're right of -4, it's above the x-axis.
Yes.
Okay, and then down here it's below. Okay, so the answer is it's all the numbers from -infinity to -5. That's all of these. And then all the numbers from -4 to infinity, it's greater than 0. If the question said less than 0, the answer would be the numbers from -5 to -4. Do you see that? Like if this said less than 0, we're asking about this part that's underneath.
Oh, okay, yeah.
Okay. All right, so we're up to 18. Again, we're solving like these questions, but if they're just different numbers, they could be exactly the same. But your instructor could also change it so that like this thing opens down and then it's a slightly different problem. So yeah, I'm not sure what to suggest, but that we don't have enough time to cover everything, but we'll cover as much as we can.
Okay.
All right. So here you treat you basically say, well, I'm just going to treat this like it's x squared minus 4x minus 60. That's kind of what your thought is. In class, you might have seen like a u substitution. Maybe.
Oh yeah, we did.
Yeah, I mean, you can do that, but you don't have to. So to solve this, you're finding two numbers that multiply to -60, but add up to -4. Okay, so yeah, you can go over, okay, -60, what could that be? You can guess, I mean, -1 and 60, -2 and 30, -3 and 20, -4 and 15, -5 and 12, -6 and 10. So there we go, we got them. But these don't add up to -4, they have to +4. So it must be 6 and -10. So that helps here. That's x plus 6, x minus 10 equals 0. But not solving x squared. These are now x squareds because of that there.
Yes.
Okay. So the next one, this is where it gets a little bit tougher because you're like, okay, so both of these equal to 0. Is x squared plus 6 ever equal to 0? And the answer is no. But you are doing this complex stuff now. So we can say x squared equals -6. So then it's x equals plus or minus the square root of -6. So now that's plus or minus, that's the square root of -1 times the square root of 6, I squared 6. And that's totally reasonable in like this class that you're in.
Okay.
Now on the right here, this is x squared equals 10, x equals plus or minus square root of 10. So those are your 4 answers. All right, so I think we've taken care of going through those 2 sheets. Where would you like to move from here? And another option is I can give you ones like the ones that are on this test review.
I think I got it. I think just the way she like reworded them had me a little confused, but I think it was all reviewed.
Okay.
I think I understand it now. But let's see. She assigned me 3.7 when I was absent, so I need to like kind of like understand it a little better because I got the notes. I just like, I don't know. I just need to like understand it more.
So we can look at 3.7 starting at number 1. Is that okay?
That's perfect.
All right. So number 1 here, I'm looking at this worksheet. I'll snip in the question. It wants you to write a polynomial. It wants you to write a polynomial in standard form. And here's what we're doing. It's x minus a factor times x minus a factor. And you repeat this, and this is your function here. But in standard form, you have to actually multiply all this out. Okay, so for example, if 4 is a 0, I'm sorry, I wrote this wrong, but we'll just, that doesn't really matter. It's x minus 4. Because 4 is a 0. This should really say 0. 2 plus I is a 0. So it's x minus parentheses 2 plus I. So you might think you're done, but the thing is these always come in pairs. So if 2 plus I is a solution, then so is 2 minus I, because the one is the conjugate of the other.
Okay.
So that means we've got another one here, 2 minus I. So now we have to multiply. This is probably the part that most students don't like very much, is you have to multiply here. So you actually want to distribute the negatives. So it's x minus 2 minus I, x minus 2 plus I. Now, you want to do the ones on the right first, because what happens is if they both have these i's, the I is going to go away, believe it or not. So you take this x and you multiply it by all three things over here. So you get x squared minus 2x plus xi. Then you take this minus 2 and you multiply it by everything in here. Now you got to be careful. I know most students write it in line here. I actually go with what's called a waterfall here, where I put them underneath the term that they match with. Minus 2 times minus 2 is positive 4. So I put that over here because this is x squareds, this is x's, this is xi's. And then the last one is minus 2i. That's something new. Okay. And then we take this minus I and multiply by x by minus 2 and I. So you get minus xi. Okay. Positive 2i. And then you get minus I squared. So if you've done this part right, and I know this is a lot of extra writing, and maybe you don't have room, but the i's always cancel. But you might be saying, but wait, what about this one down here? Well, I squared is -1. So this is -1. So it's really positive 1. So this becomes +1 there. So you get x squared minus 4x plus 5. Then you bring this one down, x minus 4. So we're not done. We got to do the same thing again. We got to multiply x times each of these.
Okay.
So you get x cubed minus 4x squared plus 5x. And again, my preference is to take, like when we do the next one, is to line them up vertically. I know a lot of students just write them over here. I think that's harder, but that's my opinion. Minus 4 times minus 4x is positive 16x. And then minus 4 times 5 is minus 20 here, -20. The reason I like it this way is you can just combine them vertically, pretty quickly here.
Mm-hmm.
Get your answer. Now 3 is actually easier, but I guess in some ways it comes after number 1. So we'll look at that next. A lot of writing on these. A lot of students aren't prepared for that. So as I mentioned before, your polynomial function is it's always x minus the 0, x minus the 0, and so on. And these i's always come in pairs. So it's I and then it's negative I. And you might be thinking, well, how would I know that? Well, if you write in this form a plus bi, I is like saying 0 plus 1i.
Mm-hmm.
So this one is 0 minus 1i, because the only thing that changes is this operator in the middle. So the zeros here, this is a 0, this is a 0, and this is a 0. So it's always x minus the 0, x minus 5. Okay, that makes sense. X minus I, x minus negative I. Let me know if you want me to cover this again, because this is critical. The rest is just a repeat of what we did in the previous problem.
No, yeah, I understood that.
So this is x minus 5, x minus I, x plus I. So again, you want to do this first, and this is just straightforward FOIL. X squared plus xi minus xi minus I squared. I squared is -1. The outer and the inner always cancel. So this becomes x squared plus 1. And then you have this x minus 5 here on the left. So now I have to FOIL again. So you get x cubed plus x minus 5x squared minus 5. So you might reorder it here. X cubed minus 5x squared plus x minus 5. All right, is that okay?
Yeah, that makes sense now.
Okay. Where should we go from here?
I think I can do 13 and 15. We can move to 19 and 20.
Okay. All right, so 19 is kind of a repeat of the one we just did. It's actually like the one I would want us to do first, because the form is so simple. It's x minus 5, x minus a minus 4. It's always x minus the 0, x minus the 0. So this becomes x minus 5 times x plus 4. So now we're just going to FOIL. So that's x squared plus 4x minus 5x minus 20. So that's x squared minus x minus 20. And I guess reasonable to assume we're going to go to 22.
Mhm.
Okay. All right. So it's very similar to the first two that we did on this page, except that it's roots instead of i's. But do you see how these are just switch in operators?
Yes.
That's because these are conjugate pairs, 1 plus, 1 minus. So you still do the same thing. It's x minus the 0. So in this case, it's x minus 1 plus square root of 2. And then x minus 1 minus square root of 2. And then it's x minus 3. So we distribute the negative x minus 1 minus square root of 2, x minus 1 plus square root of 2, x minus 3. Okay, so now we want to FOIL the ones on the left here, and you want to do like the ones that are matched up, even though they look worse. If you do them right, the roots and the i's go away. So it's the same thing. You're gonna take x and multiply it by everything. So it's x squared minus x plus x square root 2. And then you do this minus 1, so you get minus x plus 1 minus square root 2.
Mhm.
And then you take this minus square root of 2 times x. So you get minus x squared root of 2 plus square root of 2, and then minus square root of 4. Like I mentioned, if you do it right, these cancel. So you get x squared minus 2x. Now this minus square root of 4 is really minus 2. So we can actually bring that right there. That's minus 2. And that gives you minus 1 for that. Okay, but we're not done because we still got this x minus 3. We bring that down from this line here. So now you want to multiply everything by each term. I'm going to go this direction, like with the x and then the negative 3. So it's going to be x cubed minus 2x squared minus x. And then the minus 3 times each is minus 3x squared plus 6x plus 3. So you got x cubed minus 5x squared plus 5x plus 3. All right. Where to go next?
53.
53. Okay. All right. So I usually make this long plea to students that never is effective. It really needs to go to the teachers. The problem with this one is that you have to basically guess and check to do this right. So what I'm going to do is help us by guessing the first answer. by basically, I'm gonna graph this, and once you know one of the zeros, it really helps here. So there's a 0 at. See, this one's really horrible because one of the zeros is at 1/2, the other one's at -2/3, the other one's at -3/2. So really brutal here, but we'll do it with we'll use the 1/2. Okay, and then 12, 20, -1, -6. We're use synthetic division here. So use synthetic division to reduce it, and then it usually becomes something that you can solve with either by factoring or quadratic formula. So we bring the 12 down, and this doesn't seem like it's going to work. Did I graph this right? Okay. Okay, so that's I guess it does work. So that's 6, 26. You're adding vertically. 13, 12, half of 12 is 6, so it does work. So that means that this is a 0, and you might think, oh, it's x minus 1/2, but it ends up being 2x minus 1 as the preference. So that's a side thing. Now here's what we got left. So this is 12x squared plus 26x plus 12. And definitely don't like this form. So we're gonna bring a 2 out. So it's 2, 6x squared plus 13x plus 6. Okay, so now we're going to multiply these two numbers together. So 6 times 6 is 36. So we want two numbers that multiply to 36 but add up to 13. I'll save the suspense. It's 4 and 9. And this is the grouping technique. So this middle term becomes plus 4x plus 9x plus 6. Do you see that? Okay, so now it's grouping. So you gotta figure out, okay, what goes into both those? It's 2x That becomes 3x plus 2. And then you immediately write that over here, 3x plus 2. You got to figure out what goes here. And you're like, oh, a 3. So this becomes 3x plus 2 times 2x plus 3. Bring this 2 down. And then you got to bring down this 2x minus 1 that you did previously. So the thing that they want is this factored form, and that's what you have here as your final answer on that one.
I think I could probably do the rest of 3.7, but on 3.8, it's the first one. It's number 19. Can we go over that?
3.8, number 19.
Yes.
Okay. We're just going to use this. We're going to do it analytically. Yeah, by hand, basically. Okay, this is so this is one of those like where you got this sort of horrible situation where you end up getting these really big numbers. When you multiply 4 and 36, you get 144. And so you're trying to find two numbers that multiply together to give you that. They have to multiply to negative 25, so they both got to be negative. So like, I think like negative 16 and negative 9 does it. Okay, so that means you have 4x to the 4th minus 16x squared minus 9x plus 36. Equals 0. So now it's grouping again. So this, oops, that's to the 4th. So this is 4x squared. And that gives you x squared minus 4. That's a squared. So then you're at x squared minus 4 here. What do I put there? Minus 9 seems to do the trick. So that's 4x squared minus 9 times x squared minus 4. And then you set each of these equal to 0. So you set 4x squared minus 9 equal to 0. X squared minus 4 equal to 0. So on the left here, it becomes x squared equals 9 over 4. And then you take the square root of both sides. So x equals plus or minus the square root of 9 over 4. You can square root the top and the bottom. So you get plus or minus 3 halves because you can take the perfect square of both of them. This one here, it becomes x squared equals 4. Again, very important. When you take the square root of both sides, it's plus or minus. X equals plus or minus square root of 4. X equals plus or minus 2.
Oh.
Okay, so this one, all they're trying to get you to see here is that you can do this by hand. You can do this like what appears to be a horrible, difficult problem by hand, and then you can graph it if you want to see the answer.
Yeah, I think what just threw me off were the coordinates at the bottom.
They're giving you the window to look that up. So if you did want to graph it, let me just try to be helpful here with this last one. This is your x min, x max, y min, y max. That's all it is. They're trying to help you to find where they are.
Okay, that makes sense.
All right. Well, this is a great place for us to stop. Thanks again for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Perfect. Thank you.
You're welcome. Bye now.